Hello again, everyone. Welcome back to our series of videos. This is the first video for programming of the L9100 air column. And before I get into the details of programming, I just want to explain a word about common program parameters. Common program parameters are items which are common to all of the 8 available part setups in the column, and they won't change as you select different part setups. They include the security codes, the external input configurations, the station number, the column number, and the serial output data protocols. So all of these items will remain constant within a column regardless of which setup you select. Now, once you enter the program mode of the column, the first item of the main menu which comes up is Setup. And if you use the up or down arrow keys, you can scroll through all of the main menu items. Now, if you press Enter when you're on the Setup menu, this will take you into that submenu which has 7 programming selections. The first one is Polarity, plus or minus. Changing this causes the bar display to reverse movement direction. A positive polarity is generally used for measuring the outside diameter of a part, usually using a donut-type air fixture, and a negative polarity for measuring inside diameters using a spindle gauge fixture. With positive polarity, increasing air back pressure will raise the bar display, and with negative polarity, an increasing back pressure will lower the display. And you can toggle between plus and minus simply by using the up or down arrow keys and then pressing the Enter button to accept. The second item on the setup menu is Units. When you press the Enter button, you will be presented with a submenu where you can select between inches, metric, and degrees. The third item on the setup menu is Range. This allows the user to define the display range. Now, if the setup was programmed for inch operation, the range can be scrolled from 1 thou full scale to 100 thou full scale in increments of 1. And if it was programmed for metric operation, then the range goes from 20 to 1000 microns in steps of 10. And if the setup was programmed for degrees, the range will move from 0.1 degree to 10 degrees in steps of 0.1 degrees. The next menu item is Nominal. Now here the user can enter the nominal or the ideal part size. This is done 1 digit at a time by scrolling each digit to the desired number and pressing the Enter button to move to the next digit. The digit being changed at the time will be red in color. At any point, pressing the back key will move the current digit being edited back by 1. If you press Enter at the last digit, it will accept the value as entered and return to the main menu item. The numeric value will be added to the column to the tolerance value, and so the total will appear on the digital display. So therefore, when the bar display is at mid position, the value seen will be the nominal part size. Next item on the setup menu is Max Master. Now again, you can use the up or down arrow keys to change the bar and the digital displays simultaneously to the point on the display which will represent the Max Master size that you have selected for the masters being used. The numeric value is usually stamped on the master itself. Ignore the colors of the bar lights, as these can be configured independently. And be careful not to mix up the min and the max masters. If you can't reach your required master size, or if it is too small of a spread, then you'll need to change the mode gain selection and press Enter to store this in memory. The min master is the next item on the display in the setup menu, and it is similar to the max master. Once you've moved the bar display to the point you want for your min mastering value, then press Enter to store it in memory. The next item on the main menu is called Manual. Now this menu item allows for manual adjustment of the electronic zero and fine electronic gain. These two controls are changed automatically during the auto mastering process in order to calibrate the column on a periodic basis. And we will be discussing this in a separate video, but they can be adjusted manually in this menu. The controls will move from approximately -2000 to +2000 by pressing the up or down arrow keys. And you can pulse the button to move one digit at a time. The numeric values are simply there to give you a reference of where you are in position of the electronic gain or the electronic zero. If you hold the button in for more than 3 seconds, the values will change by tens, allowing for quicker movement in the setting. Ideally, you want to operate the column with these values somewhere close to the zero positions. This will give the auto mastering function the greatest amount of room to move during the mastering process. In other words, you don't want to operate with the gain at plus 1800 if you can avoid it. Whenever you're doing a recalibration involving moving the pneumatic spread or zero controls on the front panel, you should first set both of the electronic controls to their mid positions. The next item on the main programming menu is the mode menu. Now, the mode gain is a coarse electronic gain setting. It ranges from 1 times to 16 times gain in factor in 6 steps. This allows the user to find the best coarse electronic gain setting for the fixture design. Determining which gain setting to use is generally a matter of trial and error, as it will vary with the gauging fixture design. For a new setup, we generally recommend starting with an 8 times setting. If manual mastering shows that there is insufficient range with the min and max masters, then the mode gain can be increased to a higher value. And if the range is too great, likewise the mode gain can be decreased. This affords the maximum flexibility for a wide range of fixture designs. It is, in effect, an electronic gain range, but you should not confuse it with the manual electronic gain control, nor with the pneumatic spread control. So all three of these things will affect the gain of the column. The next item on the programming list is the limits menu. And here we have a submenu which will come up when you press enter. High and low specification limits and approach limit set points. This affects the status out connector voltages. There's also an output type, which has 5 arrangements, and we'll explain that in a bit, and you can also see about this in the manual. And the output state, which is a reversal of the normal operating status for the limits. Specification limits are set points which we establish to determine if a part is good or bad. There is usually a region of measurement which qualifies a part to be good, generally represented by the green lights in a bar display, or sometimes just called OK. And anything outside of this region is a bad part. Now, sometimes users also wish to establish approach limit set points, which are small regions at the outer edges of the OK region, letting the user know that a part is near to being declared bad. The set points not only are identified by color changes on the bar display and the LCD display as the user sets this up, but also determines the status output conditions. Therefore, an output can be configured to cause a voltage change, which is the standard configuration for a bad part, or as an option, a relay contact can signal that the part is bad, which is, I mentioned, is an option. However, the one thing to note is that the bar display colors do not necessarily have to match the limit set points, as they are set independently. Most often you will set them up to match those points, but just to be aware of that they aren't necessarily the same thing. On entering the limits menu, there are 7 options. The first is the high limit. Pressing Enter places the column into a mode where the up or down arrow keys can move both the bar and the digital displays to the point where you wish to establish the high limit set point. So above this point, a part will be considered to be bad. Again, as with the master set points, ignore the color changes of the bar lights for this purpose. The low limit set point is similar. Any part measurement below this setting will also be considered bad. The approach limits are done in a similar manner. Just remember that the high approach should be less than the high limit, and the low approach should be higher on the bar scale than the low limit. The output state menu has 5 possible status output configurations, which establish the criteria for the status output change. For example, you might wish to change an output if the measured part is outside of the OK area, or you might wish to have it respond to the display only if it exceeds the high limit set point. The manual for the column explains the various possible configurations. The output state menu allows you to reverse the output from normal. For example, if in the normal mode a relay contact output is closed when the display is in the OK region, by changing this to reverse, you can have it be open when it is in the OK position. So this completes our video for this part 1 of the programming. In part 2, we'll be discussing some of the remaining items such as the display menu, the user functions, and a few other things. Thank you for joining us today.